Describing functions. Linear equation. An equation whose solution from a straight line on a coordinate plane. Linear function. A function whose graph is also a straight line. Now, a proportional is if it is also a straight line that goes through the origin. Now remember that the origin is when you have the ordered pair 0, 0. It's where the x and the y-axis intersect. Alright, so let's take a look at example 1. On example 1, the temperature at dawn was 8 degrees Fahrenheit and decreased steadily 2 degrees Fahrenheit each hour. The constant rate of change is the 2x. Okay, and we have an initial of 8. Okay, and we want to state whether the relationship between the time and the temperature is proportional or non-proportional. So if we take the ordered pairs 0, 2 times 0 is 0, 0 plus 8 is 8. Now, right there, this is a big indicator that this is not a proportional relationship. To be a proportional relationship, it has to pass through the origin, and this is not going to pass through the origin. Yes, it is a straight line, but does not pass the origin. And this is just going through the rest of the substitution process. 2 times 2 is 4, 4 plus 8 is 12, 2 times 4 is 8, 8 plus 8 is 16, 2 times 6 is 12, 12 plus 8 is 20. But no, this is not a proportional relationship. Not proportional. Alright, and the reason is does not pass the origin. Okay, example 2. State whether the relationship between x and y equals 5/10 x is proportional or non-proportional, then graph the function. Okay, so if we do a process column, we can do like we had in the example before. Let's say we had 0, 1, actually it's going by 2, so let's go by 2s also. Let's call this 2 and 4. So let's do 0, 2, and 4. Alright, and then our rule is 0.5x, and we want to know what our output is. So if we do 0.5 times 0, we get 0. You plot the ordered pair, 0, 0 is right there. Okay, then we have 5/10 times 2. 2 times 5 is 10, and then we go over 1, so that would be 1. And then if we did 5/10 times 4, we would get 2. So if we plot these ordered pairs, we have 2, 1, about there, and then we could go over 4 up to, if you wanted to do maybe one more, you could. Let's do 6.5 times 6 would be 3. about there. Okay, so then we would draw our best straight line. That did not make a dot. Okay. So yes, this is a proportional relationship. Why? Because it passes through the origin and it is a straight line. All right. Let's take a look at example 2. On example 2, it says a square tile has a side length of x inches. The equation y equals x squared gives the area of the tile in square inches. Determine whether the relationship between x and y is linear. Okay, so if we have the substitution 1 squared, which is 1 times 1, which is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. When you graph this, the ordered pair 1, 1 is here. 2, 4 is here. 3, 9 is here. 4, 16 is here. This is not a straight line. It's more like a curved. This is actually like a parabola, but we haven't gotten to that yet. So this is not a proportional relationship. Because it is not a straight line. Okay, let's take a look at number 3. On number 3, it says a soda machine makes 2/3 gallon of soda every minute. So the total amount y that the machine makes in x minutes is given by the equation y equals 2/3 x. Use the table and graph to determine the linear, if x and y is linear, and if so, is it proportional? So right here it has a table set up for us, and if you want, you can do a substitution with that too. So 2/3 times 0 is 0. 2/3 times 3, this can cancel out. You get 2. You can do 2/3 times 9. This cancels. You're left with 6. Okay, and then if we have y equals 2/3 x, and this time we know that this is 4, and we don't know what x is, we can divide both sides by 2/3, or you can multiply by the reciprocal, which is 4 times 3/2. This simplifies. You get 1, you get 2, so you have x equals 6. Alright, so let's plot the ordered pair. We have 0, 0. We have 2, 3. So we have 4, 6. And we have 6, 9. This is a linear relationship, and it does pass through the origin, so it is proportional.